We'll do now some application about Faraday Law and a small application about Lenz's law. So consider a rectangular coil of 20 turns. So we have here the number of turns subjected to a magnetic field V equal 5T minus 2 Tesla. The resistance of the coil is 2 ohm. The first question is verify the existence of electromagnetic induction phenomenon. So here, in order to verify the existence of electromagnetic induction phenomenon, we must have phi is variable. So if we look here, we know that phi is equal to NBS cosine theta. And since we have B depends on the time, so B is variable, this means that phi is variable. So which means that we have electromagnetic induction phenomenon exists. Part 2, calculate the magnetic flux. So the flux is equal to NBS cosine theta. We have the number of turns is 20. V is 5T minus 2. And S at the surface, now here we have a rectangle. So the surface will be equals to side times length times width. So it's 20 times 5, but must pay attention, times 10 power minus 4, since you have centimeter and centimeter, times cosine. Now the angle theta will angle between B and N, which are opposite, so the angle is 180 degrees. So we'll get as answer here minus T plus 0.4 Weber. This is for the flux. Part 3, calculate the value of the electromotive force. So according to Faraday Law, we have E equal minus d phi over dt. So by derivative, we'll get E equal to 1 volt. Now, part 4, deduce the value and the direction of the induced current. So since the circuit is closed, then I have an induced current, which is equal to E over R total. And here we only have R equal to 2 ohms. So we'll have 1 over 2, which is equal to 0.5 ampere. And I want to find the direction now. If I notice I is what? Positive. So if I is positive, then in this case, it will be as, we'll get I induced has same direction as positive chosen. Okay, what is the direction of the positive chosen? If we look here at the normal is outside. This means this is the positive direction chosen, and the current has the same direction, so this will be I induced. This is the direction. Now, exercise number 2. A copper rod of length D equal to 10 centimeter moves on a parallel conductor rails whose plane is horizontal and lying in a uniform magnetic field B, which is upward. So this is the value, and we have the resistance R equal 5 ohm. The area is given by S. So if you notice here, the area is variable. So first thing who's the variable point. Part 1, name the phenomenon that appears in the circuit. So the phenomenon is electromagnetic induction. Now, if I want to verify why, since F is variable, this means the flux is variable, so we'll have electromagnetic induction phenomenon. Now, we continue, determine the expression of the flux. So the flux is equal to NBS cosine theta. And here we have N is equals to 1, B we have it 0.4, and S it's 0.25 T plus 0.01. Now times cosine theta, and theta is the angle between B and N. So I will choose here a positive direction. Let's suppose I choose the positive direction like this. So in this case, normal will be upward. So the angle between B and N will be equal to 0. So it's cosine 0. Then the answer of phi will become 0.1 T plus 0.004 Weber. Part 3, determine the electromotive force in the circuit. So here in this part, I have E equal minus d phi over dt. So I'll do the derivative, then we'll get equal minus 0.1 volt. Part 4, determine the direction and the value of the induced current. So if I want to find the direction first, so I look here, I have E is negative, This means the current also is negative. So if I is negative, I induced implies I induced has opposite direction to the positive direction chosen. يعني إذا بدي أجي أطلع على الرسمة, if this is positive direction chosen, يعني ال I induced بطلع بالعكس. This means it's going from N to N. And I want to find also the value of the current. So I is equals to E over the resistance, which is equal minus 0.1, and over the resistance it's 5. So we'll get equal minus 0.02 ampere. Now the last question is determine the direction of the I-induced current, but using now Lenz's law. So if I want to if I want to use Lenz's law, this means I want to explain. So here, the first step, أول شيء حدد who's the variable. So the variable here, and this is the positive direction chosen. إذا بدي بطلع على the variable here when I'm moving MN, so the variable is the surface. The surface is what? The surface is increasing. So first, I will tell him S is increasing. This means I will have a creation, there will be creation of F induced, which will oppose the increase. Then this means creation of F induced, which will try to decrease the surface. هذا بيعني انه لازم تكون ال F induced كيف؟ بدي احاول صغير السيرفيس. So هذا بيعني F induced is opposite to F. Then I trace F induced in the opposite direction, and according now to the right-hand rule, which we will use I, B, and F, the thumb and the two fingers. So we'll get, so هون بقدر أطلع the direction of I induced according to this rule. So حيطلع عندي then, if I look, we have B is upward, we have F to the left, so we'll get I, it's moving, I induced, it's from N to M. So this will be I induced according to the right-hand rule. So the ملاحظ, if I use Lenz's law or I use the Faraday law, we'll get the same answer for the direction of I induced. Last exercise. Now consider a rotating coil of 100. So here we have 100 turns, and if cross-sectional area S equals 0.4 meter squares, we have N, we have S constant, we have also B is constant, but who's the variable here? The variable is the angle. So the angle theta is equal to 10 pi t, and where I have an internal resistance R equals to 2 ohm. So calculate the magnetic flux of the coil. Part 1, phi is equal N B S cosine theta. We have N is 100, B is 8, S is 0.4, and it's cosine 10 pi t, which will be as answer 320 cosine 10 pi t. This will be 5. We notice it's variable and whatever. Calculate the electromotive force E of the coil. So part 2, according to Faraday law, E equal minus d phi over dt. Now here we must pay attention. 320 is a constant. So what I should do, where I will do the derivative is here. And what is the derivative of the cosine? The derivative of the cosine, it's minus sign. So we'll get here 320 minus bracket. The derivative of the cosine is minus 10 pi sine 10 pi t. So the answer will become at the end equal to 3200 pi sine 10 pi t. Part 3, knowing that the coil is in a closed circuit, so we have a closed circuit here, deduce then the value of the induced current at t equal 1 second. Now, in order to find the I induced, it equals to E over R. This is E, and R is equals to 2. So by dividing E over R, we'll get as answer 1600 pi sine 10 pi t. But the question is at t equal 1 second. So now implies at t equal 1 second, I substitute. So by substitution, I will get I induced equal 1600 pi and sine 1800. So it's equals to 0 ampere.